Assalamualaikum warahmatullahi wabarakatuh. In this video, you will learn about ratio and proportion. The meaning of ratio and proportion in Bahasa Indonesia is the same, which is perbandingan. But actually, ratio and proportion has the different meaning. To know what is the difference between ratio and proportion, and also how to solve problem related to ratio and proportion, let's see the following explanation. Ratio is a comparison between two numbers. Ratio can be written in three different ways. The first is word form. You can write as A to B. The second is column form. Can write using the symbol of division, A colon B. To read this, it is the same. We can read as A to B. The last way to write ratio is using fraction. So we can write as A over B. Because it is fraction, it means that the number of B cannot be 0. And you have to remember that ratios are expressed in the simplest form. Because ratio must be expressed in the simplest form, so we should simplify ratios. For example, here there is a ratio 21 to 35. How to simplify this ratio? The way is same as simplifying fraction, or same as finding equivalent fraction. So we need to divide both number with the same number, which is the greatest common divisor or the greatest common factor. The GCF of 21 and 35 is 7, so we have to divide 21 and 35 by 7. So we have 3 to 5. If there are 3-part ratio, then all the 3 parts must be divided by the same number. For example, 6 to 12 to 9. The GCF of 6, 12, and 9 is 3. So we divide all of the number by 3. So we get the ratio is 2 to 4 to 3. Another example of ratio. For example, there is red counters and blue counters. If the question is what is the ratio of red counters to blue counters, so you need to count the red counters and blue counters. Writing ratio is based on the word. If the red comes first, then you need to write the number of red first. Then the last is blue. So here there are 9 red counters and 3 blue counters, so the ratio is 9 to 3. The GCF of 9 and 3 is 3, so we need to divide both number by 3. So we get the ratio is 3 to 1. It means that for every 3 red counters, there is 1 blue counter. So what if the question is, what is the ratio of blue counters to red counters? It is also the same, 3 to 1. No, actually, if the word is blue counters first, then we need to write the number of blue counter first. So the ratio here is on the contrary of the first ratio. Means that 3 to 9. Again, we need to simplify this ratio by divide both numbers by 3. So we get the ratio of blue counters to red counters is 1 to 3. It means that for every blue counter, there are 3 red counters. Another example here, if in a classroom there are 6 boys and 12 girls, so there are some way to write ratio. For example, the ratios can be part to part. It means that we compare between the number of boys and girls. So the ratio of boys and girls is 16 to 15. And then the ratios can be part to whole. It means that we compare between the number of boys or girls to the number of all students. So here we have the ratio of boys to the all students is 16 to 31. If a ratio is part to whole, and then you can divide and find a decimal or a percent. For example, ratio of boys to the all students is 16 to 31. So you can divide 13 by 16, so you have 0.156, or you can write in the percentage. It means that 51.6% of the students are boys. Ratios can compare two unlike things. For example, Joe earned $40 in 5 hours. It means that the ratio is $40 per 5 hours, or we can simplify, so it becomes $8 per 1 hour. When the denominator is 1, then this is called as a unit rate. What about simplifying ratios with the different units? If the ratio has different units, then we need to change the units as the same units. For example, simplify the ratio of 90 pence to 3 pounds sterling. So the units is different, then change into the same units. For example, we change the units of pound sterling become pence. So 1 pound sterling, it means that equal to 100 pence. So 3 pound sterling is 300 pence. So the ratio become 90 pence to 300 pence. After the unit is equal, then you need to simplify the ratio by dividing with the GCF of the two numbers. So you need to divide by 30, so you get 3 to 10. It is also another example of simplifying ratios with the different units. For example, simplify the ratio of 0.6 meter to 30 centimeters to 450 millimeters. Change all of the units into the same unit. For example, we change into centimeters, so we have the ratio 60 centimeters to 30 centimeters to 45 centimeters. After the units is equal, then we need to divide by the greatest common factor. The greatest common factor of 60, 30, and 45 is 15. So we divide all of the number by 15. So we get 4 to 2 to 3. What about simplifying ratios containing decimals? So we can simplify it by writing it in whole number form. For example, here, simplify the ratio of 0.8 to 2. we can multiply both number by 10. If we multiply 0.8 and 2 by 10, so we will get 8 to 20. 8 to 20 we can simplify again by dividing both number with the GCF, which is the GCF is 4. So we will get the ratio is 2 to 5. The next is the example of simplifying ratios containing fraction. For example, simplify the ratio of 2 over 3 to 4. To simplify these ratios, we need to multiply by the denominator. The denominator is 3, so we multiply both number by 3. So we will get 2 to 12. 2 to 12 can be simplified again by dividing both number by the GCF. The GCF of the both number is 2, so that we will get 1 to 6. Next, look at the following illustration of ratio in our daily life to make you more understand.
Mom, I'm thirsty. Please make a glass of orange drink for me. Okay, Vinay. Wait, Mom. I want to see how to make it, so that I'll be able to make it for my friends when they come in the evening. Mom, how did you know what to add and how much? It is written on the bottle. To make a glass of drink, take 1 cup of orange squash. Pour it into a glass, add 3 cups of water to it, and then mix them well. Your drink will be ready to serve. Mummy, please make one drink for me too.
From the illustration, there is a mother and his daughter and his son. His son wants to know how to make a glass of drink, so that if there are his friends come to his house, then he can make a drink by himself. The mother explained that the recipe is written on the bottle. To make 1 glass of drink, you need to add 3 cups of water to 1 cup of squash and mix them well. It means that the ratio of water and squash is 3 to 1. So, if the daughter wants to make a drink, so there are 2 persons, it means that they have to make 2 glasses of drink. So how much squash and water that he needs? So we need to multiply the ratio by 2 because they want to make 2 glasses of drink. So they need 6 glasses of water and 2 cups of squash. What if there are 15 of his friends want to come to his house? Then how much squash and water that he needs? So based on the ratio of water to squash is 3 to 1. If you want to make 15 glasses of drink, so you need to multiply both number by 15. It means that you need 45 cups of water and 15 cups of squash. The next is about proportion. So a proportion is a statement of equality between 2 ratios. For example, we can write it as A over B is equal to C over D. There are 2 types of proportion, which is direct proportion and inverse proportion. Before I explain about the two kinds of proportion. Let's see the example of the problem related to proportion here. Proportion is a statement that says two ratios are equal. For example, in an election, Marcel got 3 votes for each 2 votes that Shannon got. And Marcel got 72 votes. How many votes did Shannon get? So we can write here, Marcel to Shannon 3/2 is equal to 72 over n. Because proportion is the two ratios that are equal, you can see in the numerator 3 is equal to 72. It means that if you want to change 3 becomes 72, you need to multiply by 24. So, to find the value of n, it means that you need to do the same way, which is multiply 2 by 24. So you get 48. It means the value of n is 48. So Shannon got 48 votes. Actually, it is also the same as the way of finding equivalent fraction. If you want to find equivalent fraction, then you can multiply or divide both numerator and denominator by the same number. Here also the same. You want to find the value of n, so you need to multiply by the same number, which is 24. The next is the explanation of direct proportion. Two quantities are said to be in direct proportion if they increase and decrease at the same rate. For example, if we compare between speed and distance, it means that the speed that a car travels is directly proportional to the distance it covers. Thus, if the speed is increased, then the distance that the cars cover, it also increase. And it is also on the contrary. If the car double its speed, and then it will cover double distance in the same time. If the car halves its speed, and then it will cover half the distance in the same time. If the car is at rest, it won't cover any distance. That is, if its speed is 0, then the distance covered is also 0. What about this problem? Let's think about this problem. There are 5. Please think that which problem is directly proportional. Speed and travel time, or how much you earn and how many hours you work, or the distance and the amount of gasoline needed, or the number of people working and the time needed, or the last, the number of books and the price. Let's think about it so that you will understand which one is direct proportional. This is the example of problem related to direct proportion. If your car gets 30 miles per gallon, how many gallons of gas do you need to commute to school every day? The distance from the home to the school is 5 miles. It's also the same from school to the home. This problem related to direct proportional. Let's think about the problem first. Don't think about the number. You compare about the distance and the number of guests. It means that if you pass through long distance, so you need more guests. It means that the number of guests increase, then the distance also increase. Or on the contrary, if the distance is decreased, then the number of guests is also decreased. Let X be the number of gallons we need for a day. So we have the proportion 30 miles over 1 gallon is equal to 5 miles, because we need to calculate the distance from home to school and then back to the home again. So we add 5 miles over X gallon. Because the units is equal, then we don't need to change every unit. So we have 30 over 1 is equal to 10 over X. Can you see here how to solve this one? You can do cross multiplication. It means that 30 times X will be equal to 1 times 10. So we have 30x is equal to 10. So x is equal to 1 over 3 gallon. It means that to commute to school every day, you need 1 over 3 gallon. The next example, if you use 1 over 3 gallon a day, then how many gallons would you use for a week? We can also use proportion to solve this problem. Let T be the number of gallons we need for a week, so we can compare 1 over 3 gallon over 1 day is equal to T gallon over 5 days. The units is the same, so we don't need to change. And then we directly solve 1 over 3 over 1 is equal to 3 over 5. 1 over 3 over 1 is equal to 1 over 3. So we do the cross multiplication again. We multiply t by 3 and also we multiply 1 by 5. So we got 5 is equal to 3t. Means that t is equal to 5 over 3 gallons. We know that he needs 5 over 3 gallons a week. So if the price of gas is $3.69 per gallon, and then how much would it cost for a week? Again, we can use proportion to solve this problem. For example, S is the sum of the cost for a week. Then you need to compare $3.69 over 1 gallon is equal to S dollars over 1.67 gallons. The units is the same, then you need to do the cross multiplication. So you multiply 3.69 by 1.67. It is equal to 1 times S. So S is $6.16. It means that the cost for a week is $6.16. Let's see this problem. It is still related to the previous problem. If you pay about $6 a week just to get to school, what about weekends? If you travel twice as much on weekends, say drive 10 miles to the mall and 10 miles back, how many gallons do you need now? How much would it cost totally? How much would it cost for a month? please solve this problem. Think proportionally, it's all about proportion. We can look at the previous example again to make it clear how to solve this problem. The second kind of proportion is inverse proportion. Two quantities are shaped to be inversely proportional if, as one quantity increases, the other quantity decreases at the same rate. For example, if we compare about the speed of cars and the distance, the speed that a car travels is inversely proportional to the time it takes to cover the same distance. So if the car doubles its speed, it will take half the time to cover the same distance. If the car triples its speed, it will take a third of the time to cover the same distance. If the car halves its speed, it will take double the time to cover the same distance. This is the example of inverse proportion. It takes one person 1 hour to put 150 letters into envelopes. How long would it take 5 people working at the same rate to put 150 letters into envelopes? Look at the story first, don't look at the number. If we compare between the number of people and then the time, so the more people there are, the less time it will take. So it is said to be inversely proportional. 5 people will take a fifth of the time to put the same number of letters in the envelopes. It means one person takes 1 hour, so 5 people take 1/5 of an hour. So 1/5 of 60 minutes is equal to 12 minutes. So if there are 5 people working at the same rate to put 150 letters into the envelopes, it will take 12 minutes. What about this problem? Please think about this problem. Which problem that shows inversely proportional? Speed and travel time, how much you earn and how many hours you work, distance and the amount of gasoline needed, the number of people working and the time needed, or the last the number of book and the price. Look at the following graphs. You will understand the difference between direct proportion and inverse proportion. The following graph shows about the number of book and the price. And then this graph shows about the time and speed. For the first graph, if you compare between the number of books and the price, it means that if you buy many books and then the price will be higher. So the number of books increase and then the price also increase. If the number of books decrease, then the price also decrease. It means that this graph is directly proportional. For the second graph, compare between time and speed. If the speed is higher, then the time will be less. So this graph shows inversely proportional problem. To make you more clear about how to solve direct proportional problem and inverse proportional problem, so here I will compare two problems. The first problem shows direct proportion problem. If you order more wood, then the price will be higher. So the number of wood increase, the price also increase. It is directly proportional. The The second problem, a job can be finished by 9 people in 16 days. If the job must be finished in 12 days, how many more people are needed? It compares between the number of people and the time. If there are many people working, then the time will be less. So, the number of people increase, the time will be decreased. It is so inversely proportional problem. How to solve this problem? Look at here. You need to write the proportion first. For the first problem, you know that it is direct proportion, and then for the second problem, you already know that it is inverse proportion. So for the first problem, the proportion is 40 over 50 is equal to 300 over 8. If the number of wood you mention from the top, and then for the price you also mention from the top, it is for direct proportion problem. For the second, for the inverse proportion problem, the proportion is 9 over b is equal to 12 over 16. So if you mention the number of people from the top, and then you have to mention the days from the bottom. So it will be inverse. So we have 9 over b is equal to 12 over 16. The top is 9 people. It is as numerator for the first fraction. For the second fraction, the numerator must be from the bottom, which is 12. That's the difference between how to solve direct proportion problem and inverse proportion problem. And then the next step is the same, which is you need to do the cross multiplication. So for the first problem, you have 48 is equal to 300 times 50. For the second problem, you have 12b is equal to 9 times 16. And then for the value of a is 375. For the value of b is 12. So you understand about the difference of how to solve direct proportion problem and inverse proportion problem. For the second problem, actually the question is how many more people are needed. The answer 12 people is not the answer. We need to calculate the additional people because there are 9 people, and then to work 12 days we need 12 people, so we need to subtract 12 by 9 so that we get 3 more people. So they need 3 more people to work so that their work will be finished in 12 days. That's the end of the explanation of ratio and proportion. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.